classic slide or classic picture. I met it in one of the Jam Asia. What was those called? BlackBerry Jam conferences. So, anyways, thank you very much for coming in. My name is Shadid, as you have heard so far. I manage a small team of enterprise solution managers who works with enterprise customers and partners, basically enterprise DevRel, helping them with their app development and unblocking issues that they might be having. Today, we're going to talk about headless apps. How many of you have built a headless app? All right, that's pretty good. So it's still valid to do it. So before I get started, I wanted to set some goals and expectations of, by the end of this presentation, what you will know or have an understanding of. Firstly, we're going to start off with what headless apps are, and then talk about the types of headless apps we have. And then with headless apps, it comes to lots of responsibility. So we proactively, as a platform, set some rules and restrictions on the headless apps so that the user experience is not compromised. So we're going to talk about those. Then we're going to jump into the communication between headless app and a UI app, how those communication can happen, what the platform provides. And last but not least, we're going to see how you can create a headless app from scratch, sort of like a live demo, but a coding demo. So headless app, you probably are familiar with a regular UI application. Right? You only have one UI app compiled into a bar file that goes onto the device, gets installed and runs. But in a headless app, you actually will have two separate projects. One for the headless service, the service that doesn't have any UI, just runs by itself. And the other is the UI application. That's what shows when the user clicks on the applications icon. So let's just keep that in mind, that headless app is actually a combination of two independent apps packaged in the same bar file. And there are two types of it, the two types of headless applications. The first one is short running, and the other one is long running. Short running headless apps, basically, from the point they get launched, they can run for 20 seconds. And that's all the time you're going to get. So if you're writing a short running headless application, from the time it gets launched, you have 20 seconds to live or die. And within that 20 seconds, you have to finish your work. So why do we have a short running service? What's the point? The point is there are lots of use cases that actually does not need the headless service to run all the time. So for example, if you are a weather app, let's just take a wild example, a weather app. User moves to a location where the weather needs to be updated. So it's changed the location significantly. Your app needs to update the weather. So the headless app can actually register for a geofence when it gets triggered as soon as the geofence changes. Then it can update the UI and whatnot. Be prepared for the next time the UI gets launched. On the other hand, long-running headless applications do not have that restriction. So if you're writing a long-running headless application, once the headless application launches, it can run forever until you intentionally kill it or it crashes for some reason. So those are the two types of headless applications. So these are just concepts I'm throwing at the table just to keep in mind for later when we do the hands-on coding. With that out of the way, let's talk about triggers. So the type of headless app determines whether your app can run for 20 seconds or your app can run forever. Those are the short running versus long running. Triggers determine when your headless application gets launched. For example, there is a trigger called system startup. So when the device boots or reboots, if your headless app registers for that trigger, it will get launched on device startup. So there are a bunch of triggers defined for your benefit. You just have to pick or choose the right trigger for your headless application. So the main concept of triggers is that it determines when your headless application gets launched. And triggers are basically special events generated by the system. And whenever those events occur, the system actually goes through all the apps who are registered for that trigger and just launches that headless service. So there are a bunch of triggers, like I said, defined in the platform. When Headless app first launched in 10.2.1, we had 4 triggers. We had the push message triggers, which invokes your headless application whenever there is a push message for your application. We have a geofence trigger, which triggers your headless application when a geofence enter or exit event is generated. We also had something called the port-directed SMS trigger. Do not confuse this with user SMS that goes to the device's inbox. This is meant for SMS sent to custom ports that are being listened by an application on the device. So any application on the device can actually listen to a custom port, say 5.
So you're talking like Unix domain sockets or something?
No, it's the SMS protocol, how the SMS message comes to the device.
Oh, so it's the same thing as text messaging, but
Yeah,
internally it never goes outside the
Never goes to the user's inbox.
Uh.
It's so, as far as I remember from BB7 days, if it's sent to port 0, it goes to the user inbox. If it goes to a non-0 port, then it tries to find an application that's listening for it. If there's no application listening for it, it just gets lost forever. Cool. So that's port-directed SMS trigger, and this is not meant for use in a user-based SMS scenario.
So is there a user inbox SMS trigger?
No. So this is actually specifically created for some of the carrier partners we have. They needed this for some of their applications. Not very popular, for sure. It's not very widely used. The most popular one is device startup. Everybody wants to get launched at device startup because you want your service to be running, right? And you want your service to be running from the time device starts up until it dies. So that's a device startup trigger that triggers your application or headless service when the device boots or reboots. In 10.3, we added a few more triggers until we decided we're not going to add any more triggers. I'm going to tell you why we're not adding any more triggers. So in 10.3, we introduced incoming email trigger. So if you register for it, your headless app is going to be triggered if there is an incoming email in any of the email accounts of the user. The app updated trigger is invokes your headless application when the app gets updated through BlackBerry Word. So you might want to show the user, something that says your app is updated or something. I don't know. Maybe your release notes, what's new in this version, things like that. App install trigger triggers your application when the application gets installed. So as you can imagine, app updated trigger. When your app gets updated, both app updated and app install trigger is probably going to be fired if you're listening for them. I might be wrong on that, but anyways, we'll.
If it's someone else's app, or if it's your app being installed for the first time and you trigger it when it's installed, how can you run it without presenting the list of permissions that you require to the user? Wouldn't it be like a crippled experience
That is a good question. So what happens is once your app gets installed, before any of this trigger, actually triggers your headless. Well, when your app gets installed, it'll try to trigger your headless application because it has app install trigger registered, right? But what's going to happen is the user is going to get prompted. That's the first thing that happens before your application runs a single line of code. So the permission screen, there's no way around the permission screen. So if the user doesn't give you background permission, then you don't run headless. Your headless doesn't get triggered, it just fails. Cool. One other popular trigger that we introduced in 10.3 is the timer-based trigger. With this setup, you can either create a one-time timed launch of your headless app, or you can have a recurrent timer that launches your headless app at a certain interval. So say you want to launch your headless app every hour. You can register for that kind of timer, and your headless app will get launched every hour. So, yeah.
So just before you go on, how much flexibility is there with timer? Like, is it just you have to set a delay until you run, or do you have like all the flexibility of, say, cron to say, you know, run me once a week or something? Or
so if it is once a week, I can't remember the exact APIs, but if it is once a week, you basically set up a recurrent timer.
Okay.
The system will take care of, you know, reboots and system crashes and whatnot. It's going to recover and pull up all the timer and start them again. But you can basically say, this is the first time it's going to launch, and then launch it every this many milliseconds.
Okay, so there's some sort of scheduling system.
Yeah.
Okay.
Yeah.
And also, before you go on, you said BlackBerry's not bringing in any more triggers.
Right.
And you were going to say why.
I'm going to say why.
Oh, okay, but after the next slide.
Probably it's at the very end of the presentation.
Oh, okay.
Yeah. Cool. So that's Headless Apps. Before I move on, any other questions? Cool. So let's talk about the responsibilities that come with headless applications and the rules and restrictions we impose on the headless app, just to, you know, for the broader good of the device or the user experience. As when you develop a headless app, it is strongly recommended that you keep its footprint at a very minimum, right? Do not make it big in terms of memory or in terms of CPU chugging. So we assume you all will do that. But on top of that, there are some set rules on headless apps that I wanted to discuss. First one is, since it's a headless app, there is no UI involved in that process. So in your headless project, you cannot use any of our UI libraries. That is the BB Cascades package. You cannot actually include it in any of the header files. You cannot include it in your .pro file where you import all your libraries. So BB Cascades is completely banned for headless apps because there is just no point. And BB Cascades takes a lot of memory and a lot of CPU processing most of the classes. But we just completely removed it for headless apps.
So in other words, you can't use OpenGL?
Never tried that. But why would you do that?
It's really great for doing processing.
What kind of processing?
Processing of images that you're not going to actually display.
Oh yeah, you could do those things.
Okay.
Yeah, absolutely. Yeah, but you just cannot display anything or render anything on the screen.
So you can still do rendering, just off screen.
Off screen, yeah.
Okay.
Yeah. You can do image processing and whatever you want. It's just that BB Cascade is the gateway to displaying anything on the screen. You just don't get any screen instance in a headless app. It's just those are blocked as well. Second rule or restriction is headless apps cannot invoke a UI application. Because imagine what's going to happen if your headless app just invokes a browser and just slaps it on the user's face, right? It's going to be very annoying. So there is definitely reasons for why we block this, and just can't do it. No UI invoke from headless app, but you can invoke other headless applications or other services. That's fine, that's valid. But you cannot invoke UI applications. The other restriction is headless application cannot invoke itself, resulting in just running it forever, anyways. But you cannot do that either. I think this is the last restriction. Hope there is not too much restriction. Headless applications are restricted to 7 to 25% CPU, depending on what the system have available at the moment. It's going to give your headless application anywhere between 7 to 25% of the CPU time. And it's also restricted by 3 megabytes of heap RAM. So all your news and mallocs cannot go beyond 3 megabytes in a headless app at any given time.
Okay, now you said heap RAM. So your stack RAM can actually go higher?
Yeah.
Okay.
Yeah.
So you can do like char bracket 65,000?
Good, potentially. As far as the rule goes, stack is actually wide open. Yeah, sure.
So you get you
why
can
would
actually
you do
use
that?
like 8 gigs of memory.
Yeah, you are asking questions I will never do. You'll never do either.
Well, I would never do that.
Yeah,
but just
I understand. Yeah, but yeah, Stack is, as far as I'm concerned, it's wide open. You can define anything you want in Stack. And in terms of CPU priority, headless application actually is at the very bottom. So the system core services and the foregrounded UI applications has the highest priority in terms of CPU, and then comes the minimized or active frame applications that the user is not using actively at that point, and the last one is headless. So in terms of CPU scheduling, if you're wondering, headless application has the least priority.